Hi, everyone. Thank you for joining. My name is Shane Murphy. I am Technical and Sales Director at Ashgrove. We'll be going through this Home Energy Upgrades webinar today. If you have any questions, you can type them into the Q&A box there at the bottom of your screen. I'm keeping an eye on it here on a parallel screen, so you'll see me looking. You should be able to hear me okay. I've done a sound check. Everything seems to be working okay. So we'll start away. So we'll be doing a quick introduction to Ashgrove. We'll talk a tiny bit about Ashgrove's experience in this industry. We'll talk about the grant types and the eligibility criteria. We'll talk about the administration and the process. We'll talk a little bit about the technical side of the various upgrades. We won't be talking about much of it in today's talk, simply because we'll be caught for time. We do that once a month in a longer seminar, which actually is the second Saturday of every month at 2 o'clock. And that's a face-to-face seminar at the GAA complex at Mallow. Contact us for any information on it. We'll talk a little bit about case studies. We'll talk very little about funding options, but there are more and more funding options available as these grant programs get more popular, and they're supported by the main banks now, and of course SCAI and the government. So a tiny bit about SCAI. Of course, their main mission is to assist through incentives or regulation the transition to a low carbon future over the next 3 decades. That, of course, is under real pressure now. Before now and 2030, they have something like 500,000 houses to upgrade, so the pressure is on. And to that end, I suppose they've increased 12 or 16 months ago. They've increased the grants to reflect that. So, tiny bit about Ashgrove. We're in business since 2001. We've been working with SCAI since 2006. We're a registered one-stop shop, which means, I suppose, essentially that we are an approved advisor and contractor for anybody considering home upgrade works. So we're also a Bord Gáis Premier Solar installer. We have about 16,000 systems in operation around Ireland and the UK. Last year we did about 1,400 installations, so it'll be significantly higher than that in 2023. And of course, today a lot of people don't understand that, especially when there's grants involved, that more than 50% of the work goes into paperwork and so on. And I suppose that just takes the cowboy behavior out of the whole thing. Of course, the downside to that maybe is that it makes it a little bit more convoluted often, but at least if you go ahead with it, you're guaranteed a good result. So, as I say, questions, I'll be keeping an eye on the on the parallel screen here. And lastly, we're supposed to mention when we're talking about any grant related stuff that all the energy upgrade grants come from the government of Ireland. We're obliged to scream that every time we get an opportunity. Anyway, I've done it for today. So tiny bit about Ashgrove's experience. We do everything from small houses or apartments up to what you see here on the left hand side of your screen is an apartment block that we did in Reading, just outside of London. We did that probably 4 or 5 years ago. That's a £2 million project. Very high-end apartments, air-to-air heat pumps, a gas engine producing electricity, the thing called the combined heat and power plant. Again, we're showing the top right is a very high-end house here, 60,000 square foot house. Again, heat pumps, heating and cooling the house, heating pools, doing hot water, etc., etc. Lastly, a project in Scotland, which we would have done a lot of. This is a 2,000 kilowatt system taking heat from a lake and heating a factory. Again, to put that in perspective, 2,000 kilowatt system, your typical house that we're looking at in Ireland today is probably somewhere between 5 kilowatt and 15. 2,000 is an enormous system. So we typically build those in Ireland, put them together, test them, and then take them apart, ship them to wherever they're going. And at least it's only plug and play when you get to commissioning it after. We're not going to be talking about these today, other than we use them for three, I suppose, reasons. It demonstrates, number one, that our background is renewables, so we're a technical company. Number two, I suppose we have a strong project management capability. And number three is that all of these projects require, I suppose, it is a part of project management, but it's a strong quality process. So everything has to be checklists. So, and that's why we just use those as maybe three examples. We won't be talking about it anymore, but from here on, we're talking about housing. So the benefits of home energy upgrades should be obvious, I suppose, but I'll go through it. I'll try not to bore you. Obviously, we'll be expecting to reduce the energy costs, which is extremely relevant the last year or two. We'd expect in a lot of cases that the homes will be warmer. Not in all cases, some of them they're already warm enough, it's just that they're paying too much for it. Obviously, the environmentally friendly side of it is front and center for more and more people. Certainly it's for us and the government. The houses, when we're finished, or I would say 90% of the projects that we do, the house has to get to a B2 or better when we're finished. That's not the case in one of the grants. You don't have to get to a B2. We'll talk about it as we get to it. It obviously, when you upgrade your home, you're increasing the value of it. The statistics tell us today that if you go from a D2 to a B2 in Dublin, you're increasing the value of your home by 16%. Outside of Dublin, you're increasing the value of your home by 12%. So to go from a D2 to a B2, 12% is a significant jump in valuation. On top of that, I should say, by the way, that you're into a green mortgage territory. So once you're above a B3, if you're a B3 or better, you're into green mortgage territory. We'll talk a little bit about it, a tiny bit about it. Most of these cases, we talk about better air quality. That's something we have to be very mindful of, because sometimes when we improve the insulation and the air tightness in a building, we can actually have exactly the opposite effect. So you can make the air quality worse, moisture can't get out, odors can't get out, etc. So that's something that as grant administrators, whether it's through a one-stop shop or a BEC, we have to be careful when we sign off on anything that actually the air quality is better, or at least no worse. So the green mortgage can be anything up to 0.9% lower than a non-green mortgage rate. I'd have to say that 0.9 is the biggest change we've seen. I would say more typically is probably somewhere around 0.4 or 0.5. But over 20 years or whatever, and certainly on a bigger mortgage, it's still a significant amount. So we see some people contacting us maybe to insulate an attic or to put up solar panels just to get them maybe to a B3. They want to do the minimum amount of work to get to the B3 just to get to that green mortgage rate. Anyway, and of course, we have green loans available as well through the major banks these days. So it's for maybe somebody who's just carrying out maybe a smaller amount of work, maybe attic insulation, wall insulation, and a heat pump or something like that. So you're not into a full mortgage situation, but 10, 20, 30, 50,000, something like that. So why are we doing these webinars and seminars? We've been doing them for about 10 years now, and the reasons have changed. Today we're talking about upgrades. 10 years ago, we were talking about heat pumps. Well, where do they work? Where do they not work? All of these untruths surrounding heat pumps in particular back then, but today we have the same to do with solar panels. You know, we hear all the time that they work even if the sun isn't shining, and you know, those things simply aren't true. And same with the grants. People hear that they can get grants for windows, doors, or floor insulation, and yes, they are true, but only in certain situations. So we're here, I suppose, to bring some order to the situation where the customer essentially is talking to Ashgrove, and we're the you know, in some cases we're the one-stop shop. In other cases, one-stop shop doesn't maybe work, and in some, of course, we're hearing as well that it's getting bad press. But I think that we've been told that the one-stop shop is going to be this magic bullet, and for probably 50% of the projects we see, it's simply unsuitable. And so then people get annoyed with it, but you know, it was simply the wrong tool to begin with. So we'll talk about today the one-stop shop. We'll talk about a sister grant of the one-stop shop. It's called the BEC, Better Energy Communities Grant. It has all the same advantages without some of the limitations. Now it has, one-stop shop has benefits over it as well. And lastly, we'll talk about the BEHs, or what was previously known as a BEH, which is an individual measure grant. So either way, you're coming to us, I suppose, hopefully, so that you can ask us the questions and we'll give you a sort of a coherent answer. And you know, we have expertise in all the areas on the right hand side of your screen there. From BER guys, we have 5 people in house here doing BERs. Sorry, we have 5 BER people who are not allowed to do BERs, but I suppose we're monitoring what's coming in, making sure it's correct, etc. Same with windows, doors, insulation, solar PV, we do in-house. SCI, we're talking to them, you know, weekly, so we have a strong relationship with all of these guys. So we're packaging that so that you don't have to understand all of the stuff that you're confused about. U values, HLIs, heat loss indicators, you know, air tightness measures, the various grants. How do I go about it? So that's what we're here for today. So we're going to talk about these grants, some of them not much, some of them in great detail. The fully funded upgrade grant is for somebody who is for anybody who's getting a fuel allowance. So you might be getting a fuel allowance if you're a carer, for example, if you're long-term unemployed, if you're over 6 months unemployed with a kid under the age of 7. There are 7 other criteria. We don't do fully funded energy upgrades. We're not on that framework. There's about a 3-year wait list for it at the moment. So typically a lot of the people that come to us, even if they are interested in, or sorry, if they are eligible for it, they end up coming back to us for one of the other grants, just because they don't want to wait for 3 years to have a comfortable house. The individual energy upgrade, we'll talk about very briefly this evening. The one-stop shop grant is what all the phone calls are about these days. As I say, it's suitable to about 50% of the projects we see. The next one, the Better Energy Communities Grant. This is quite often a more flexible grant, and we'll be talking about it. And then we'll talk vacant house grant, and we'll talk about the derelict house grant. And we'll talk about those very briefly. And in fact, I'm going to go on to them now. So the vacant and derelict house, so this is after jumping this year. The vacant house grant is 50,000. So it's for, the house has to be vacant for 2 years or more. It has to be built before 2007. That's correct, that's just changed. So I just had to fact check that. So how they check, by the way, if the house is vacant for two years, they'll check either that the electricity was disconnected over 2 years ago, or that if the electricity is there, that the usage for 2 years has been essentially zero. All right. There are some cases where somebody might have tiny usage of electricity, for example, to run an oil boiler to keep heating going, or some background heating. Out in the country, we often, in the case of farms or whatever, they might have electricity coming from the house to run electric fencers or something like that. Provided we can put a coherent argument forward, they seem to be reasonable enough to deal with. You're allowed, well, in terms of getting the vacant grant, you have to live in the house. If you don't live in the house, you know, if you sell the house within 5 years, they claw back 100% of the grant. Between 5 years and 10 years, they'll claw back 75% of the grant. But provided you live there and it's your primary residence, you're entitled to it. And secondly, as a landlord, again, provided you don't sell it, you're entitled to own one other house. There's talks of this increasing, but at the moment, it's one. So I think that's fair. We think that's fair. So in order to go and apply for the grant, you either have to show that you own the property or that you have evidence of active negotiations. To draw it down, ultimately, you need to own the property and you need to demonstrate, of course, that you've spent the money on the relevant things. So the derelict grant, so this is an additional 20,000 on top of the vacant grant. So, and to get this, you need to demonstrate that you paid more than 70 to do up the house. And in order to get this, you need to get a report. Sorry, first of all, a report confirming that the property is either structurally unsound or dangerous, or, you know, bits of the roof falling in, or, you know, something that constitutes derelict. So, you know, in some cases, the house might be already on the derelict house register, or you just, failing that, you need to get an engineer to go out, take photos, write a report, and just, I suppose, substantiate his findings that it's derelict. So, and then in doing the second part of that, you need to produce a quotation for the works. The other thing you need to supply is that either a letter from the confirming either the local property tax is up to date or that it is exempt. So if it's properly derelict and you can prove that, you know, it has been vacant and derelict for 10 or 20 years, well then, you know, they'll just give you a letter to say it's exempt. Whereas if it was only vacant for the last few years, you need to, you know, you need to demonstrate that it's the property tax is up to date, or bring it up to date and get your letter accordingly. And then any other supporting documentation, but yeah, that's, you know, tends to be site specific, right? So that's it. So that's the vacant and derelict, guys. I'm keeping an eye on the questions. You guys fire away. I'm going to jump straight into why heat pumps. Now, the reason I'm doing that early in the presentation here, we get asked an awful lot at the moment, the way electricity prices are gone and so on. Heat pumps are getting a bit of stick in the same way that the one-stop shop is getting a bit of stick, unfairly in our opinion. And so I just want to maybe take 2 minutes to explain why they're being shoved on us, right? And also, in some cases, we're hearing that the running costs are high, and in some cases that's true. In some cases, it's simply not true. But, you know, at least give you an understanding. So the reason that heat pumps are being pushed on us more and more as each year passes, they're 70 to 80% greener or less carbon than oil or gas, right? So that's a simple fact. Our electricity is coming more and more from wind and hydro and so on. And when we put electricity into these heat pumps, it allows the electricity is used essentially to harvest energy in the outdoor air or in the ground or in lakes, as we saw a while ago. And so as a result, your heat coming out of your heat pump and into your house is 70, 80, maybe up to 90% less carbon than oil or gas. That's it. That's why the government are pushing us this way. Whether it's cheaper to run or anything else, they don't really care. Of course, it is cheaper to run, or should be cheaper to run. In some cases, we see that's not the case, but there's always an explanation. So I'm going to give you just some of those, so you know, these ones that we actually, yeah. I'll explain in some of the cases, I suppose, why are they getting bad press? Sometimes it's just poor heat pumps, and we don't yet have this accumulated knowledge like we have for maybe cars or something like that. So we know some cars are efficient and some aren't. We don't yet know what that, sorry, I'm saying as a country now, as whatever is on the island of Ireland, 6.5 million people. Your Joe public simply doesn't understand that that car is efficient and this car is not. in the heat pump world, the same thing exists, but we don't have that accumulated knowledge yet. Secondly, we often could have a good heat pump, but installed in the wrong place. And we often describe this as taking a good car, an efficient car, but we decide to go drawing silage or something with it. Well, clearly that's not going to work. Again, we don't know that yet. And talk about your average guy in a shop selling this stuff, or your average installer out. We don't see that these guys yet have this sort of expertise. We have other people then who, you know, take out an oil boiler maybe and put in an electric heat pump, and so they come back and they see their bills. My bills, Shane, have gone up €1,000, and you look at it and you say, yeah, they are gone up €1,000, but your €2,000 oil bill is now gone, so you're €1,000 better off. So sometimes we see that. I wouldn't say a lot, but probably 20 or 30% of the time. And then the last one we probably see a bit, people comparing the cost of their oil a year or two ago, so a running cost now, and of course, yes, the electricity cost has gone up 3 times in the last 3 years or something like that, but oil has gone up significantly as well. So, you know, they're comparing today's electric costs with a heat pump to their oil cost 2 years ago, and you know, but yeah, and probably the last one we see then is people, when they get used to having heat and in their head it's cheap, they tend to use more of it. I come across that literally every week. Somebody setting up 23 degrees, they suspect it's maybe slightly on the high side, but it feels lovely. And you know, each degree costs you about 4% additional on your running costs, and so people don't realize that. So anyway, so but the running costs are very simple. I won't bore you with it, but I'll just run one very quickly. I'm looking for in here, guys. Sorry, my mouse gone. Sorry, no. Okay. Yeah, sorry, I have a question there. Is it compulsory to install a heat pump, or can you pick any 3 upgrades? There's no mention of 3 upgrades, even though it's in the public that you have to have 3 or more. That's not true. We'll come to the criteria in a second, but it is not essential that you have to install a heat pump. However, it's very hard to hit the other criteria without a heat pump. We'll come to it. Okay, sorry, I had a technical glitch there. So the running cost of a heat pump, just very quickly, I'm not going to bore you, provided the house is getting to a B2 or better, your energy for your house, you'll need about 30 kilowatt hours per square meter per annum. To picture that in old money, that would be 3 litres of oil per square meter per annum. Sorry guys, I'm having awful trouble with these. So if I had a house at 170 square meters, I would simply multiply that by 30, and that would give me 5,100 kilowatt hours. That's essentially half an oil tank of energy required for my house. I would add hot water to that then. So a typical house in Ireland would use about 3,500 kilowatt hours. So in total, that's about 8,000 kilowatt hours. And to heat that using a heat pump with an efficiency of 330%, it'll cost me about €1,000. And that's using today's figure of 40 cents. If I was to use an oil boiler to produce that, it'll cost me about 1,556. Now that's an 80% oil boiler. If it's 90%, it'll be less than that. But you know, 80 is probably realistic for a kind of anything older than 7 or 8 years, right? So there are the figures. If you put in a poor heat pump, or you're going to have a higher running cost than that €1,000. If you take a good heat pump and give it to a guy who knows nothing about it, it's going to be a higher running cost than that. If you put down carpet on top of underfloor heating, it's going to be higher than that, because the heat pump has to work harder to get the heat through the floor. You know, all logical things, but we hear every sort of silly thing happening all the time. So, so good. I'm going to keep going. I can go. So I won't spend any time with this now, guys, but an electric heat pump, if I put 1 kilowatt into it, I'm typically taking 4 kilowatts from the outdoor air. So I get 5 kilowatts out. So I'm paying for 1 and I'm getting 5 out. Some of you might have heard of this term COP. It's like efficiency. And in the case of a gas boiler or an oil boiler, if I put in in the case of an oil boiler, just so we can picture it, if I put in a litre of oil into it, I'm getting some percentage, call it 80% of that out in usable heat. The reason we use heat pumps is for every kilowatt hour we put in, we're getting multiple times the heat out. So we don't call it efficiency because it's, you know, percent. We can't have more than 100 per 100. So we use this term COP. So we'd be expecting 4 or 5 out. And of course, I need to change that figure. Actually, it's an old slide and I keep meaning to change it. If I put in electricity at 20 cents, which it might be for night, rate electricity, by the time I divide that by 5, I'm getting about 4 cents. So that would make it kind of 3 times cheaper than oil. But the other reason is carbon. If my electricity is has carbon footprint of, or carbon embodied carbon of 250 grams, if I divide that by 5, it's about 50 grams per kilowatt hour, whereas oil is probably 280 or something like that. So it's significantly cleaner than oil or gas. I keep going. So I'm checking again my questions, guys. Okay, yeah, so we'll cover that while we're here. Do we need to have a perfect insulation for a heat pump to work well, or is it possible to get good efficiency in an old building with only thick walls, for insulation? And this is something we fight with the SAI about all the time. You know, a heat pump essentially is producing cheaper heat than an oil boiler or a gas boiler. So now, I suppose as a government, we can understand that they want to take, as they call it, a fabric first approach. So they don't want cheap energy going into buildings where it's essentially camouflaging inefficiency. So, you know, you can imagine putting up solar panels. The government give you us a grant to put up solar panels to camouflage your inefficiency when you haven't, in fact, fixed the problem in the building. Still in all, we do want to insulate buildings correctly. However, take the opposite case to that. We had a project today, which is a church. We're going to heat it with heat pumps. They cannot do anything with it. It's using a lot of energy. So under this grant, because they're using a lot of energy, they will not give them a grant to put in a heat pump. And when you think about that, we just say if somebody was saving, I'm just going to say 30% now as a round figure. If a church was spending, I'm going to say 20,000 a year, and they're going to save 30% of that by putting in a heat pump, they're going to save 7,000. If you have an A1 rated house where they're spending 500 euros a year and putting in a heat pump is going to save me 1/3 of that, I'm going to save whatever that is, 160 euro. My figures aren't letting me down. So in that case, it makes less sense financially to put in a heat pump in a good house, whereas a really, really bad house, or church in this case, financially it makes a lot more sense as it gets worse. So we can argue all the time whether it makes sense or not. I would look at it on a case-by-case basis. But what I can say to you is that you won't get grant funding unless your house is at a B2. That's not to say we have houses there that are at D's or E's or whatever it is. Okay, you won't get the grant, but is it now still the right thing to do? And in many cases it is. However, there's a disclaimer with that. If you want to, you know, we do hear all the time that when you turn a heat pump on, you have to leave it on. That's silly talk. I get cross whenever I hear it. You can control a heat pump just like a boiler. You can turn it on, you can turn it off. But if you look at a house, as we often view it, as a kind of a leaky bucket, and if you picture that we're trying to fill it with water all the time, and we take, again, you know, it's leaking a little, well, then it takes very little to keep it topped up, right? To keep it full. So it's leaking a small amount of water into the top. However, if we take, as we just spoke about, that church where it's leaking water in a huge way, and I really only want to use the church on a Sunday, well, what we would do in that case is we would turn off the tap, leave the bucket go empty, and on Sunday morning, before we'd want the church, we need a big tap to fill it up quickly. So in the second case, if we have a really leaky building, we do want to turn off the heating system. And I'm just saying there that we often hear from your general plumber, oh, you have to leave a heat pump on. You turn it on, leave it alone. They're designed to do that. And in the second case, like the church, it's simply not true. So I hope I'm after answering your question there. Contact us if you need more information on it, but it's an interesting one. We debate this even among ourselves here. Sometimes I have people who think it should be on, but I totally disagree with it for that type of project. So the BEH, the Better Energy Homes, this is for an individual measure grant. Just want to check my time, guys. So an individual measure grant would be for somebody who wants solar panels only, maybe a heat pump only, or attic insulation, wall insulation, and so on. Now, you can, despite what I've just said, you can do some of those together, but the homeowner, by the way, must apply for these grants. They must pay for whatever works are done, and then ultimately they get the grant back retrospectively. It typically takes about 6 weeks. In this case, it's not too bad, but that's kind of it for the BEHs. Unless anybody has questions on it, I'm not going to spend time on it, because most of the people that are on these calls are either BEC or One Stop Shop, and I'm going to jump onto them straight away. So if anybody has questions, fire them at me and I'll deal with them. But other than that, I'll keep going. So, apologies, 2 seconds. Good. So, so that's the grant amounts for the individual upgrades. I'm going to skip straight past that, guys, and I will show you the difference. By the way, the one thing written on the bottom of it there is that if you apply for any of these grants as an individual measure, you have 6 months in which to complete the work, which, to be fair, is maybe fair enough, because any of this work should not take more than 6 months to complete. Whereas if you're getting into a one-stop shop or a BEC, you know, you're probably, well, you mightn't have to be, but you might be ripping the house apart, taking out the floors, ripping out the windows, maybe literally taking the roof off. So all of those projects are going to go on more than 6 months. So, you know, you're definitely into a one-stop shop or a BEC there, which they allow you 12 months for. So I'm going to skip on. So BEH, just to compare here, you have the heat pump. I've written here, by the way, specialist contractor. So most of the installations here have to be done by a specialist contractor. But the heat pump grant is 6,500. You have an air to water, and sorry, an air to air. We won't be talking about it here. We'd use it for apartment blocks maybe or something. Insulation, cavity wall insulation, solar PV. You get up to €2,400 for that. But you can see here that your standard individual measure grant, or we often shorten it to BEH, you can't get the heating system upgrade, which is €2,000. You can't get the heat pump launch bonus, which is €2,000. You can't get floor insulation, which is €3,500. You can't get windows, which is €4,000 for a detached house. 2 external doors, you can get €800 each for those. Mechanical ventilation, which is $1,500. You'll see it in a second, but you're missing out on all of this if you go the BEH route. Now, that's provided you are doing them anyway. But if you are doing them, you can either go the route of a BEC or one-stop shop. And so you can see here that not only will you get 6,500 for a heat pump, you get 2,000 to upgrade your radiators. You'll get 2,000 of an additional bonus for the heat pump. This is a typo here. I thought I fixed it last week. 3,000 for rafter insulation. You can get that one way or the other. It shouldn't be down here. Floor insulation, €3,500. And so it's not that you would go taking up a floor just to get at that grant, but if you had a house that you were gutting anyway, well, they'll give you 3,500 for the floor insulation. They'll give you another 2,000 for underfloor heating, etc. So it adds up fairly quickly. So you can see here the doors, the ventilation, the air tightness, and then down here, I didn't mention it a second ago, €2,000 for project management. So we look at some case studies of this in 2 seconds. Yeah, okay. So fire in the questions there, guys, for anything you want. So, sorry, that's a mistake in there. So a one-stop shop So why would I use a one-stop shop compared to a BEC? So a one-stop shop, number one, it's for somebody who is looking at kind of a greater attack on the house. So they're considering attic insulation, wall insulation, maybe the doors need to be changed or the windows, or looking at a heat pump or solar panels. So what they need to consider is that the house has to get to a B2 when it's finished. Under the BEH we saw a while ago, that is not true. You don't have to get to anything when you're finished. It doesn't really matter. If you just want to do your attic insulation, you can get the grant and they're not questioning your BER. Whereas in a one-stop shop, you have to get to a B2. The next thing SCI are saying here, I've just stolen this off their website. It's a fully managed solution by a company like Ashgrove. So we will take it from beginning to end. You don't have any obligation other than to sign up and to pay whatever the difference is between, you know, if the project costs 50,000 and the grants are going to be 30,000, your obligation is to pay the 20. It's our obligation, I suppose, under the one-stop shop to fund the project and go off at the finish and claim the grants. So, and this is one of the main selling points. The customer is in this case only paying the net amount, so the 20,000 and so on. So the houses have to be, in this case, built before 2011. And it's saying here the house has to be B2 or better when it's finished. There are two other criteria which we'll come to in a second. We have to demonstrate for one-stop shop that the house was bad to start with. So we call it, for argument's sake, say an E. And when I'm finished, the jump to a B2, I have to demonstrate that I suppose, how do I describe it? I have to demonstrate that the house is significantly better. We measure that in kilowatt hours per square meter every year. So if we were to compare it to a car, we're going to say that the car was doing 30 miles to the gallon before we started, and now it's doing 60 miles to the gallon. So it's significantly better somehow. Well, in the case of the house, I'm going to say last year it was consuming 300 kilowatt hours per square meter, and today it's consuming less than 100, right? So we've demonstrated that it is now much better than it was previously, and that's measured in kilowatt hours. So that's probably the big one. So when somebody asked there earlier about the three measures, there actually is no rule of three measures. It's 100 kilowatt hours. So bad to start with, significantly better, 100 kilowatt hours or more. The B2 are the two big ones for the one-stop shop. And then, of course, if you're getting a heat pump, we have to do one more figure, which is a heat loss indicator, to demonstrate that the house is quite efficient and not losing more than, we'll come to it in a second, but it's measured in watts per square meter per degree Kelvin. I won't bore you with the science of it, but it's a calculation we have to do. And sometimes people get frustrated with us for not giving them the grants, but the long and the short of it is, you know, it's simply we're given the rules, we have to play by it, and that's it. So the difference between a one-stop shop then and a BEC, I'm going to say in the case of a one-stop shop, and I'm going to look at a case study now immediately. Is typically there's no other contractor on site. So, and then typically it's a project which can be completed from start to finish in around 2 months or less. We have projects there that'll only take a week or two. And again, I'm going to look at that case study now. But we have other projects which are going to go on for 10 or 12 months. Well, we tend to look at that as a BEC project, and I'll explain why. So, that's the one-stop shop. I'm going to describe very quickly the BEC here. So again, the same things pertain, multiple energy upgrades. It has to get to a B2. The same things down here before 2011. The 100 kilowatt hour still pertains. But in this case, if there's a contractor on site, what we will say to them is, okay, you have a builder, he's building an extension or he's totally gutting the entire house. He's doing his works. Well, here's what we'll do. We'll get you all the same grants, let him work away, and we will make sure that all the calculations are done, and that you know before you start that you're going to get all the grants, whether it's 15,000 or whether it's 32,000. We will make sure you're on the straight and narrow, but we're not stepping on his toes. in the one-stop shop scenario, everything that is connected to the grant, so floor insulation is an example, windows, doors, heating, all of that has to be paid for by the one-stop shop, right? Ideally, according to the one-stop shop, we're supposed to do all of the work. We are allowed to use subcontractors. But you can imagine that if your contractor is building a wall, but we're doing the window, well, if there's a problem between the window and the wall, well, who's responsible in 2 years' time? So we would have a contract with the builder, he'd have a contract with you, the homeowner, but we would also have a contract with you, the homeowner. And so now we're in a three-way contract, which for us is just a no-go. So we say that if there's a project where there's a contractor already on site, let him do the work, and we will keep him on the straight and narrow. We'll make sure you get your grants and that he does everything according to the rule book. You'll still get all the grants, but you're not paying this premium rate that you're paying for a one-stop shop. Because the reality is, if we could take that project on as a one-stop shop, we would be taking on your builder as a subcontractor. We have a charge then sitting on top of him. We have a project manager managing his project manager and all of that. And it just gets really expensive. And that's what we're seeing typically with the one-stop shop projects. They're 30 or 40% more than they should be. So we choose not to go down that route. So if it's that type of project that's 6 or 8 or 10 months, get your builder. We'll tell you what to do in terms of insulation and grants, but let him at it. So there's a contractor on site, we'll use him. And then this project will typically take 3 months to 12 months. Part of that, by the way, is selfish. Part of it is contractually it doesn't work. The second side of it is, if we're starting your house today, your builder is on site, but insulation goes into the floor. Next week, we insulate the walls and whatever. Well, you know, there's 10, 20, 30,000 after being spent now. We can't go to the government to claim any of that until the whole project is finished. Now, some people get cross when I say that because they want us to fund the project for them. You know, as much as we'd like to help, we're not a bank. And, you know, people quite often understand it. Some small percentage of people say, you know, Shane, you're obliged to do it. Well, we're not. If you want to run it through a one-stop shop, yes, you are obliged to do it. And we would say in that case, if it's a project taking 12 months, well, we will not take that project on as a one-stop shop, unless maybe if it was sheltered housing or something like that where they couldn't fund it themselves, we would find a way of funding it for them in exceptional cases. And we think that's fair. So, okay, so I'm going to look at a case here where I'm going to skip that slide. Actually, I'm going to come back to it. And I'm going to look at a typical one-stop shop case study. We did this one about 2 years ago. Semi-detached house. The year of construction was 2003. It's 103 square meters, so 1,100 square feet roughly. Semi-detached 2-story house. And they contacted us looking for solar panels. We looked at it and we very quickly knew solar panels for them was by itself as a BEH grant was a poor choice. The reason was they were falling into the one-stop shop eligibility criteria. It was C2, which wasn't that low to start with. We could still get the 100 kilowatt hour improvement by insulating the attic, insulating the walls, putting in the heat pump and the solar. And so where solar panels would have cost them about €7,000 2 years ago, in this case, we did the attic insulation. We brought the insulation up to a foot, 300 millimeters. We pumped the remaining cavity of the external wall. We did an air-to-water heat pump. We did solar panels, and it cost €8,100. So, you know, that's only €1,000 or €1,106 euro more than what a solar panel would have cost. So what you're seeing there now is the project management grant is kicking in that you can get through the one-stop shop. You're getting the bonus payment for the heat pump. In this case, it's €4,000. And that's it. They weren't getting anything else here. They were getting an extra €300 for the energy assessment. So, but you can see here the one-stop shop is after doing its job. Now, the other thing about this is, and we see this as a quintessential one-stop shop. I'll describe it like this. If we went in to insulate the external wall, and we were pumping it this morning. While the guys are setting up ladders and whatever, the guys go pumping the external walls, and well, then the few laborers can go to the attic and start insulating the attic while the other guys are doing the walls. And by midday, the external walls and the attic is done. They can go home. The following day, I'm going to say the heat pump guys arrive, and they have about a day or a day and a half, taking out the gas boiler or the oil boiler, or whatever it is, putting in the heat pump, doing the hot water cylinder, doing whatever. And the following day, the solar panels guy, the solar panel guys arrive. They go up on the roof and they run the cable down into the fuse board. And by the Friday, this is an ideal world now, by the Friday, the electrician arrives and he wires the solar panels and he wires the heat pump, and by Friday evening it's all done. So in terms of cash flow for the customer, he pays, in this case, 50% of the 8,000 day one, or we'll say when he sends the order, he'll pay us whatever that is, €4,053. And on the Friday, when it's all up and running, he pays us the remaining €4,053. And in this case, I'm guessing the grants off the top of my head are somewhere around 20,000. So the project costs us 28,000, let's say. It's up to us then to go off and wait with the government or with SCAI to get our grants. But so the customer is paying only 8, he's done. So, and we don't mind that because the project is quite quick and we go off and we get our money. It's relatively quick in the case of the one-stop shop. So we can all picture it's quick, it's easy, it's easier for the homeowner. This wouldn't be considered what they call a deep retrofit, by the way. It would be considered probably more of a shallow retrofit, not that invasive and fairly quick. So in this case, the house got to an A3 and saved 2.6 tons of CO2 per year. So a huge result for little enough money, more than what they would have paid for solar panels alone. Okay. By contrast, this fella, now this project also got the vacant and derelict grants, but I'm going to say it's a house that was built in the 70s. That one wasn't, it was older, but the house is similar in size. And here are the grants they get. So I'm just going to talk first of all about the grants they get. So these people are going off to extend it and do all of the works anyway. So in this case, instead of just getting, I want to zoom in here for you, the heat pump grant, 6,500. They'll also get 2,000 to upgrade the heating. That apartment grant shouldn't be marked there. For some reason, that's wrong. The launch bonus here is €2,000, so that's the heat pump bonus. Attic insulation, 1,300. Cavity wall, 1,700. 3,500 here in this case for your floor insulation, which they will be doing anyway. They're going doing solar. They're also going doing external wall insulation. Sorry, what did I see there a while ago? Sorry, guys, there's something after slipping in that slide there. But anyway, external wall insulation, €8,000. They're getting 4,000 for the windows, which they're obviously doing anyway. They'll get 800 for each external door, which is max. A total of 2 is the maximum. You can't get more than 2. €800 for that. And then they'll get mechanical ventilation if they're doing it. Air tightness, €1,000, and 350 for the BER and energy assessment, and they get 2,000 for project management. Long story short, that all amounts to grants, excluding the vacant and derelict, of 36,350. Now, in this case, what we will say to them is, you get your builder, whoever you are going using anyway. What we will do is we will calculate for you, and the process would be like this. You would contact us, we would go, or we would get somebody to do an energy assessment or a BER in your house, and that would give us a starting point. The house is, in this case, a G. We would say, right, it's starting as a G. It's going to get to a B2 or a B1 or an A3 when it's finished. So we're demonstrating that we're definitely improving it more than 100 kilowatt hours. We're definitely hitting the B2 and so on and so on. So we'll get you the grants, and we'd calculate the types of windows, we'd calculate the wall insulation and tell you what thickness you'd need to put in to get all the grants. And in a case like that, we would we get you the grants when you're finished. So your builder goes off and does it. You pay him 200,000, and when you're finished, we will get you 36,350 minus our fee. In a case like this, if we didn't do any work at all on the house, we would charge maybe for something like that. We would charge about maybe €4,500, including the VAT. Of course, the VAT is 23%, so that bit is no good to you, but it's also no good to us. We just collect it for the government. So we charge whatever that is, call it 4.5 in a case like that. There's also energy credits. So the energy credits on a house like that are probably worth about €1,000. We can sell them or trade them on your behalf. But you can see there that, you know, in a case like that, we would be waiting. We would have to pay the builder for the works that were done, and it could that could be, you know, it could be 100,000 or whatever it is, and we're out of pocket until we get the grants. So, you know, in that case, we would choose, no, we're not doing, we will not take that on as a one-stop shop. Our competitors might take it on as a one-stop shop, but what we're seeing is the cost of it goes, you know, through the roof. And we're seeing that literally. We saw a case of it again about maybe a month ago, where a house was using a small builder and us, the cost was about 40,000, and using a one-stop shop, it was 100,000. Both of those were after the grant. So it was 70,000 more, and it was nearly 300% higher than what the cost of it was through a BEC. So that's where a one-stop shop doesn't work, or, you know, and where a BEC is better. So I hope that's covering that. I'm going to keep going, guys. I'm just watching the time. So ask me questions if you have more on that. If you want me, I hope I've described the difference there well. It's a very important one. People get very cranky with us. They get it into their heads that a BEC is not doing what they want. It's always cheaper. Sorry, that's not true. 99% of the time it's cheaper. But so, you know, we've all been brainwashed a little bit that the one-stop shop is this silver bullet. In some cases, it's simply not the right thing. Anyway, we'll be quite open in telling you what our thoughts on it are, and so on. I'll keep going. Okay, I'll try and keep going. Sorry, where am I? This fella. So the eligibility criteria for these we've described already, but I'll hair down through them again. So the house has to be before 2011. Should take a drink. By the way, you'll find out all of this on SCI's website. It's all there. It tends to be a little bit scattered, you know. It's not all in one place. But to be fair to them, they are very easy to deal with. Now we're finding these projects are simple enough. Even the awkward ones, they're easier to deal with than previously. So to get it into a BEC or one-stop shop, house has to be a B2 or higher when you're finished. You must reduce the energy consumption by more than or equal to 100 kilowatt hours per square meter per annum. We need to do what's known as an SR50. So this is a radiator sizing calculation. We check if the heat pump is operating at 50 degrees, they can run hotter than that. They can run at 50 or 55 or 60, but the efficiency starts dropping. And so the SR50 essentially is evidence that your house is suitable for a heat pump without a higher than necessary running cost. So let me give you an example. We go into your house and we're being lazy, and we'll just say, look, the radiators are all fine, even though in reality they were designed to run with an oil boiler, which was running at 80 degrees. We're only going to be running it at 50 degrees. So one of two things is going to happen now. I either have to run the heat pump higher than it should be, 60, 65 degrees. It can do it, but the running cost goes up. It's like driving your car at 100 miles an hour instead of driving it at 60 and wondering why the fuel consumption is worse. Of course, it's going to be worse. It's running harder. The other thing I can do is I can just run it for longer. So the radiators now are smaller than they should be because of the lower temperature. And so I have no choice only to run for longer. And again, that affects the running costs. So the SR50 essentially places the onus back on Ashgrove as a one-stop shop provider or as a BEC provider to say, I have gone into Mary's house, I have looked at every room in the house, the kitchen is losing, let's say 1 kilowatt, and then we've insulated the walls, so now it's only losing half a kilowatt, and I'm now looking at the radiator, and my question is that radiator now running at 50 degrees, able to heat that room and give it the half a kilowatt it now needs? And if it can't, it's as simple as this, I have to change the radiator. But if it can give me the half a kilowatt at the 50 degrees, well, that's evidence that the heat pump will be efficient. And so it's a pain in the ass of a calculation, I'd have to say, but it's in everybody's interest that that's done properly. So, sorry, when I say it's a pain in the ass, it's a pain in the ass for us and not for you. And the last thing on that heat pump is this heat loss indicator, and that's essentially something similar to the one above it, but it demonstrates that the house is essentially losing little enough heat, and we measure that in watts per square meter per degree Kelvin. You don't need to worry about that, but it needs to be 2 watts or less. If that means that the house is leaking, as per the question at the start, it demonstrates that the house is losing little enough heat, like we were describing out of the bucket. It's losing 2 watts. Go ahead, we will give you the grant. Now, if it loses between 2 and 2.3 watts, they might still give you the grants, but they're going to ask you more questions. So they're going to ask you now about the U value of the wall, ask you about the U value of the windows, the ceiling, etc. And provided you're ticking all those boxes favorably, they will still give you the grant. Now, in some cases, we may need to air test the house. What that means is, imagine closing all the windows, closing all the doors, bar one actually. We put this big fan onto one of the doors, and they seal around it, and they turn on the fan. And what that fan does is it pulls air out of the house. And of course, in doing so, it creates a negative pressure within the house, and basically air will get sucked in through any little cracks or crevices or around the windows, or, you know, up through the floor if there's, you know, if you have a timber suspended floor or whatever. And depending on how hard, you know, if I have to pull, how do I describe this? If I have to, the harder that fan has to run, the more leaky my house is, right? I won't go into it more than that. And if it's very leaky, essentially you won't get the grant. If it's not so leaky, you will get the grant. So that's all I'd say. We nearly always know the results of those to start with. There are certain types of houses that are leakier than others, but we would, if we thought at the start of any project that we were going to be into that situation, we would tell the customer straight out, we are worried about this. We need to have a serious conversation, and we simply wouldn't all get into a situation where we're finding out it's not working. So we'd make that decision before. So I won't talk about that. I won't talk about that. It's saying there, that second last one is saying the grants may not be drawn twice, but there are several exceptions to that. You know, if you've drawn grants before for wall insulation, you can't draw it now again, but you actually can. If you got a grant 10 years ago for cavity wall insulation, obviously you can't fill the cavity again, but you can get internal wall insulation, or you can get external wall insulation. Equally, if you had insulated your attic 10 years ago and got a grant for it and brought it up to maybe 6 inches, where it might have been 2, you'd have gotten whatever the grant was at the time to bring it up to 6 inches. But today the standard is 12 inches, so they'll give you another grant to bring it up to 12. So there are plenty of exceptions. And then lastly, you have to do, in order to get into a one-stop shop or a BEC, you have to do a pre-works BER. So to show you, our house was bad to start with. It was, as I say, an EF or a G or a D or whatever it was. Here is, you know, some people don't understand why they need to do a BER before when the house is going to be totally gutted. But it's very simple. We need to be able to demonstrate to SCAI the house was bad and now it's good. And the only way the only way they'll take our word for it that it was bad to start with is a BER. So people think it's a waste of money and all the rest. Doesn't matter. Has to be done. So you do a BER. And if you're doing a heat pump, you have to do a thing called a technical assessment. So about half of the BER guys in the country are also technical assessors. It's a little bit of extra training that your standard BER guy does not have. Some of them didn't bother with going for the training, but about half of them did. So, and that means they have extra training for the heat pump. So if you're considering a BEC or one-stop shop, the BER needs to be done if you're considering a heat pump as part of it. By the way, when I was asked at the start, can I get into the BEC or the one-stop shop without the heat pump? More often than not, it's very hard to get the 100 kilowatt hour uplift without the heat pump, right? So it's hard to demonstrate that massive jump in efficiency without having a heat pump. So it is possible though, and more often than not, we tend not to see a lot of them. And I'd say it's almost nearly exceptional that something will get compliance with the one-stop shop or the BEC without having a heat pump. So now I've put in there at the bottom of that, we will discuss the above in the course of our conversations. What I would say is there's an awful lot of information in there and it's not for you to worry about it. That's why you're coming to somebody like us. This is our area, and you just need to know that we're dealing with it. Now, if there are things that you need to know, we'll tell you. The reason that we're telling you all of these is, you know, we get given out every week for not giving somebody the grant. We want to give you the grant. It's just for some reason your house isn't ticking boxes in a particular way. We can do nothing about it. But that's why we're telling you all of this. So to stop people giving out. So there's a bit to it. I have a question here. Give me 2 seconds. I've been answering them away as I'm going here. Yeah, so it's a good question. Can you accept a BER or a technical assessment from a third party, or must it be done by your company? Excellent question. We actually can't do it ourselves because, you know, as they say, well, it must be a third party. Otherwise, they view it as us, you know, being in a position where we can correct our own homework. So it must be a third party. If you don't have somebody, we will give you a list of guys around the country who are strong in these areas. Quite often what happens is we get a BER guy who's a brother-in-law or something like that of the customer. It doesn't matter to us. But if he goes out and he doesn't understand the rules, and if the house is marginal somewhere, as an example, if the house is, say, the C2 that we saw a while ago, and if he comes back and he does you a big favor and he comes back with a C1 or a B3 and he's bumped it up where he can, well, now he's after making it harder for you to achieve the 100 kilowatt hour improvement because he's said at the start that it's better than it is. And therefore, he's made it harder for you now to get the grants. So we've no problem using those guys, whoever you're talking about, for a BER technical assessment. We would really like that they understood how to achieve the criteria. So a quick chat to be had, but it's a valid question. So in 2 seconds. Now, next up is, so what are the steps? So number one, you get a BER done. I would say number one is probably come and talk to us and we will tell you, like that house we saw there a while ago, you know, built in 2003, we know straight away. You were doing the attic, doing the walls. We know, okay, you'll get the 100 kilowatt hours with the heat pump and the solar. If you were saying, I didn't want the solar or the heat pump, we'd say, right, you won't get the 100 kilowatt hours. Okay, you probably won't get the grant. You can get the BER done if you want, but, you know, in our experience, you probably won't get it. So you're spending 450 or 500 euro and, you know, you mightn't get it. But so we can talk you through that. We would know, in some cases, we'll say take the house there that was being gutted completely, where there was no windows and they were taking out the floors. 1,000,000% that house is getting the grants. The question is whether it's getting 26, 27, 28,000 or 33, 34,000, but it's definitely getting the lion's share of the grants. So we would tell that customer, hand on heart, any day, go and get your BER done and your technical assessment. Come back to us. And, you know, but in a case where we thought it was marginal, and a marginal house for us might be a house that was built, maybe call it in the 80s, maybe a dormer, and if there was a sunroom in it, that house for us is 50-50. I won't go into now why, but those houses find it very hard to get under that HLI figure, that heat loss indicator. And often they might struggle to get to the B2 without changing the windows. And, a lot of people mightn't want to do that. So we will tell you very quickly, but we'll tell you, go ahead and get the BER done. We're happy that you're getting 27,000 or 32,000, something like that. Go ahead and do it. Or it might be 10,000, it might be 15,000, we'd know. And in the cases where we don't know, which is less than 10%, we would tell you that. Proceed at your own risk, and here's where we think you are. Once you get the BER done and come back to us, we can then agree a contract. Either we're doing the works for you, or you're doing the works with your own builder, and we'll keep you between the ditches. But whatever we agree goes into the contract, and it tells them we're doing the work, you're doing the work, who's doing it, how much, prices, deadlines, fees, all the rest of it. And once you sign that, we would then apply for the grant on your behalf. So we do all of that side of it for you. In the case of the one-stop shop, once we apply for that online, we get an immediate green light there and then. In the case of the BEC, it takes a bit longer, and the reason for that is a BEC is what's known as a Better Energy Communities project. What we have to do in a case like that is we have to take 10 or 15 houses, put those 10 or 15 houses together with a community centre or a clubhouse. Obviously, that describes a little community project. We put that project together as one application, and the SEI then need to assess that to see if it's ticking all the right boxes for them. Now, however, so in some cases they might turn those down, but typically they're turning it down based on the community side of it, the community centre or whatever. But once the house is ticking the boxes, the 100 kilowatt hours, the B2 and the HLI, and provided we're hitting the other criteria, whether your house goes in with that application or the next one, you're guaranteed to get the grant. So don't worry about it. So we say there that there's a 6-week turnaround. In reality, we know it's going to start, and we'll tell you, go ahead and do the works. I'm actually doing it myself for my own house at the moment. I've started before I got the approval. Shouldn't be doing it, but it doesn't matter. They're accepting them. They want these houses in at the moment, to be fair. They're being extremely open and helpful. They want every house possible through. They're trying to report them over in Brussels as quickly as possible, and so they're extremely helpful. So once we receive the grant approval as described just there, we can start the way. We have 12 months then in which to complete the project. So during COVID, they were flexible on the 12 months. They're getting less flexible. To be fair, we find them okay. If you give them plenty of notice and you say, look, we have problems getting whatever for whatever reason, whether it's materials or external wall insulators are in short supply, etc. So we find them okay to deal with. Either way, in theory, you have 12 months in which to complete your project. So that's it. So now, 7:10. I'll give you maybe the dime tour on the solar because it's such a hot topic at the moment. I'll give you 5 minutes on it. If you want to stay on, feel free. If not, feel free. So, and this will be a very quick tour now, guys. The solar panels generate direct current as opposed to alternating current, which we use in our houses. And depending on how much energy you use in your house or how much energy we expect you will use in your house, we will put up more or less solar panels. So each one of these solar panels will generate over a year, will generate about, I'm just going to say loosely, 400 kilowatt hours. So as an example, if I was trying to generate 4,000 kilowatt hours, it doesn't take a calculator to tell you that I need 10 panels producing 400 kilowatt hours each. That gives me 4,000 for the year. If I have electric cars, tumble dryers, 10 children, whatever it is, heat pump, etc., 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 well, then I'm going to need more electricity. Well, then I will need more solar panels. I won't go into it more than that this evening, but that's the general gist of it. So if I have a surplus of electricity, you can follow this wire down, running down the outside wall, which we would never do. If I had surplus electricity, I would store it here in a battery. It's not shown in this drawing, but I would store it here. And that battery would store up direct current, which I could use later on when the sun goes down, and would save me having to import electricity from the grid. I would say probably 50% of the houses we see should not have a battery, something people find very difficult to understand because all of their buddies have batteries and they think it's only a great thing. More often than not, that's not true. And we would often, maybe the way we would describe it is, in a case like me, I'm gone in the morning at just say 7 o'clock and I'm not back as with this evening. I won't be back until late this evening, and it's sunny all day. Shane is not in the house and therefore not using electricity, so there will be a surplus, and that electricity will now can either go into a battery or will go to the grid. And in that case, you know, we would maybe choose to use a battery. So, however, in the case of our office, the sun comes up in the morning, and when it starts producing energy, the office is already at full tilt. So we're able to use that electricity as it's being generated. Therefore, there will never be a surplus, and therefore a battery would never actually be of use. I'm leaving Saturday and Sunday out of the equation there for simplicity, but you get the picture that, you know, unless I'm generating surplus electricity, I might not. The battery is only ever a cost day one, €3,000 or €3,500 kind of typically. And unless over the lifetime, 25 or 30 years of the panel, unless I'm saving more than that 3,500, well, it has only cost me money. But so roughly 50% of them deserve batteries. So from that DC electricity, in order to make it usable electricity, alternating current, which we get out of our sockets, etc., we have to pass it through a thing called an inverter. And there are two different types of inverters. We have the simple one is a string inverter. That would be where I don't have a battery. So that will generate AC electricity from me into my fuse board. And whatever is consuming out of my fuse board at that time, whether it's my tumble dryer, my television, my heat pump or whatever, we'll get that electricity. So as an example, if today the sun was producing the solar panels were producing 6 kilowatts, and if I was using 4 kilowatts at the time, heat pump, television, tumble dryer, well, the 6 from the solar would go into the through my inverter. 4 would go off to my fuse board, right? And that would negate obviously any requirement for me to import electricity. So I've no import. And then of course I still have a surplus of 2. That would go into the battery if I had a battery, but if I didn't have a battery, I could use it to produce extra hot water or something like that if I wanted. But in the case where I can do no more with it in the house, I then will export that, let's call it spare electricity, back out onto the grid, and I'll be able to sell it for 20 or 22 or 23 cents maybe. But keep in mind that tonight when I go to buy it, I'll be paying 40 or 42 or whatever it is. So they're the main workings of it, guys. Is there any questions on it? I think I've answered the bulk of them as I'm going. By the way, we do an online webinar on solar in greater detail every second Wednesday. I don't know whether it's on tomorrow or not, being honest. But every second Wednesday anyway, so make contact with us if you want to join it. So that's it. Is there anything else I feel should be said about solar? Maybe I'll just go to the next slide here and just cover this to show you the scientific side of it. So if your house is existing, which presumably it is if you're on this call or on this webinar, we might already have 12 months of electricity bills for you, showing, you know, what January is like, February, March, etc. So you'll see there typically electricity is higher in January and February, March than it is in summer. That's quite obvious. We have lights on more, we typically cook more, we typically use the tumble dryer more, the heating is operating, etc. But of course, no surprise, despite what we hear from salespeople all the time, no surprise that the solar panel isn't working as well in January as it is in June or July. So we get this kind of a typical bell curve. You know, people get emotional over that because they think, sure, look, what good is it so if it isn't really working in the months where I want it? Well, the long and short of it is we'll design it to offset about 50 to 60% of your energy over the year. We're sorry if we can't make the sun be closer to us in winter than it is, or that we're angled at this 23 degrees, that the Earth is tilted on its axis. We can do nothing about all of that side of it. We'll have to get over it, but we are saving 50 to 60% of energy use. So if you tell us what that energy use looks like, give us the bills for 12 months, we will then put it into the software, and the software will generate reports. So we'll have a picture of your house, which we can take from Google Earth. We might have put in the heights and the slope of the roof. But what that will do for us then is, if we know your house is in, I'm just going to say, Abbeyleix, we know the amount of sun that falls per year in Abbeyleix. We know that from 30-year weather data, and that will be different in Abbeyleix and Cape Town, South Africa, or Helsinki. The software will tell us that. The next thing we have to tell it is what orientation the house is at. Google Earth tells us that, and that gets pulled into the software directly, automatically. And then the last thing is we need to know, is the roof flat, or is it facing directly perfectly at the sun? When it's directly overhead in summer, we're getting maximum efficiency. And all of these things inform the software then and say, okay, John and Mary have a house that needs 7,000 kilowatt hours. And what we do then is, you can see here in the garage, we can draw on panels, and these just pop on. We draw them on, and every time we drop one on, it is calculating how much energy on that part of Ireland, Abbeyleix in this case is facing east-west, and it tells us, okay, they've gone here with, what's that, 10 panels either side, so 20 panels, and it'll tell us over the year that in this case, that the house or the solar panels are generating 6.59 megawatt hours, or 6,590 kilowatt hours per annum. But anyway, it generates a 12-page report. So you can see there it's quite scientific. If you wanted to put the solar panels, in this case, on the roof of the main house, you could probably have gotten away with maybe 16 panels in this case. It would be more efficient because they're facing the sun. And you can see there that it's even depicted that way, because the house, the south-facing roof is a bright yellow, whereas the north-facing roof is a darker color. In behind the chimney there, you can see that for X number of hours, you can see that there's shading behind that chimney. So that would tell us, if I put in solar panels there, I'm going to have to take some sort of a hit on efficiency and output over a 12-month period. Now we can deal with that with things called optimizers, which help us to get greater efficiency if we do have bits of shading intermittently. But anyway, guys, I'm going to finish it there. We could be here till Kingdom Come talking about this stuff. You can see there, this isn't a case of somebody rocking up to your house and saying, we'll fit 10 solar panels and that off you go. There is a bit of science to it. Okay. By the way, in a case where we don't know what the house would be consuming, like that derelict house we saw a while ago, we have no evidence of what that house would be. But we have a lot of data, as we said at the start. We've about 14 or 15,000 houses now done, and we have evidence from all of those that they're consuming typically somewhere, as I said at the start, about kind of 30, maybe it's 28 kilowatt hours per square meter. We multiply it, the house is 200 square meters, you multiply it out. Hot water is typically fairly consistent, believe it or not. And so you can very quickly get an educated idea of what a house will consume. And now, with houses with a lot of glass or something like that, it might be, yes, you'll have sunny days where it's taking in heat, but more often than not, in winter, glass is losing 4 or 5 times more heat than a wall. So we have to take that into consideration. But anyway, you can see that it's quite scientific. It doesn't take long. It looks like there's a lot in that, but it typically takes maybe 2 hours for a house or something like that, provided we have the data and we get something very scientific back out. And in a case like that there, if we plug into that house the type of lifestyle they have, these people in this case that we're looking at are in Limerick. I know the couple quite well. They work from home. They have 2 electric cars. They've a heat pump. We did the heat pump about 15 or 16 years ago. So we had a lot of data on this house. And so we could tell in that case, they have 2 electric cars which had 50 kilowatt hour batteries. So if they had a surplus of electricity, they put it straight into the car. Why would they be spending an extra 3,000 for another battery? However, to be fair, if they didn't have the electric cars and so on, and with 20 panels up, they would be generating a surplus of electricity, and there's a strong argument for them definitely needing a battery at that point. We can put all of those things into the software and tell the software about the lifestyle of the people involved, and then we know what the science of it is, we know where it is in the world, the orientation of the roof, and we know what the panels will do. We can choose the various panels. It might be a Jinko panel, or it might be a whatever other type of panel, and each panel will have its own particular efficiency and output and yield over a 12-month period, and even over a 25 or a 30-year period, or whatever their guarantee is. But again, we know that with great certainty before you start the project, so there's no need for guesswork. Unfortunately, we see a lot of it in our industry at the moment. Anyway, I'm going to finish up. I hope that's been useful, guys. As I say, we do these. I hope it's not coming across as salesy there. We're not selling in a case like this. This is all information for you to try and demystify all of this stuff that's going on, and hopefully it's of use to you. Pick up the phone if you need anything from us, and or if your builder or your engineer want to. We run regular training seminars like this. As I say, the second Saturday of every month we do a face-to-face seminar, which is kind of a 2.5-hour version of this, but it goes into greater detail about insulation and various other things. Anyway, I think I've covered everything, so I'm going to finish up there, and enjoy the rest of your day, and thank you for joining us.